Another form of factoring that builds upon factoring out the greatest common factor is something called factoring by grouping, and it's something that we look to consider, see if we can use anytime that we see that we've got 4 or more terms in the polynomial. And so here we got a couple of, I guess you'd say they're quadrinomials because there's 4 terms in each one. And starting with this first one, we got Rn plus 5n minus R minus 5. And one of the things that we're trying to get to, or one of the results we hope for, is that if we group these, that we'll end up with a common factor into each grouping. And in this first one, at least, it makes it kind of easy for us. But let's put these into 2 groups. And we're going to group this as Rn plus 5 and negative R minus 5. And we're going to consider those 2 individually and see if we can factor out a common factor. So over on the left side of this Rn plus 5n. Well, I can factor out an n. And if I do, I'm going to end up, after factoring out the n, I'm going to have R plus 5. So I factored out the greatest common factor of this first group, which was n. There was an n in each of the terms, and it left me with R plus 5. And now I'm looking at the second group, negative R minus 5. Well, if I factor out a negative 1, then that second group is going to be R plus 5. Both of those are negative. If I factor out a negative 1, and I'll have a common factor of R plus 5. So let's do that. So I've got negative 1, and negative 1 into negative R leaves me R, and negative 1 divided into negative 5 gives me plus 5. And I see that I've got now a common factor here of R plus 5. And then I can just combine this n minus 1, and my 2 factors for this then become n minus 1 times R plus 5. Well, you know what? Let's foil that. Let's take a moment and foil that back and see if that comes back to our original term. So I'm gonna go up here. We got n minus 1 times R plus 5. And I'm going to use FOIL to multiply these 2 polynomials, and I want to see if I come back to that original. Well, let's see. N minus R is nr, and n times positive 5, first outer, I'm doing the outer now, is plus 5n. And negative 1 times R, well, that's going to be negative R, the inner terms. And negative 1 times positive 5 is negative 5. And Shazam, look, I did end up right back there, factoring by grouping. Now, I would tell you that it's not always set up quite like these 2 that we see right here, but hey, we'll take it. All right, let's say the second quadrinomial, 3np plus 15p minus 4n minus 20. Well, let's go ahead and just see if we can put these into 2 groups, kind of like it's written. So I grouped them as 3np plus 15p, and then negative 4n minus 20. Well, I got 3 and 15, and then I've got a p in each of the terms in this first grouping. So let's factor out 3p, which then leaves us with n plus 5. And hopefully I'm going to have a common factor of n plus 5 when I factor out the greatest common factor in this negative 4n minus 20. And I can see that if I factor out a negative 4, if I factor out a negative 4 in the second group, then I'm going to be left with n plus 5. And that's what I'm hoping for. I've got a common factor now of n plus 5, and I just rearrange this, and my factors here of this quadrinomial are 3p minus 4 times n plus 5. And we could FOIL it back like we did the first one, but I'm pretty well convinced now that this is a valid method of factoring that we call factoring by grouping, where we've got a polynomial that's got 4 or more terms.